right, so this is a sample lesson of our online tutoring with our three prodigies here, Lily, Lydia, and Ian. We call it the LIL math, Lil. Um, so you'll be able to see what we do, and the software that we're using. Well, this is OneNote, and we have basically, like you see that they're writing it right now. But we're going to be switching over to Freeform, where all we can see all three students with the teacher writing on the same screen simultaneously. It's a free software from Apple. And yeah, right now we're learning Algebra 2 on factoring and also factoring with inequalities. Okay. All right. Any other questions on this one? Did this one make sense?
Yes, I think we got it.
Yeah.
Okay, so that's the same for number 22, 23, and 24. So do you want me to do the rest or is it okay?
We'll probably be able to figure it out.
Yeah.
Okay, any other questions aside from these?
Lydia needs
19.
Is that Ian?
That's the I have one just to kind of go to
This one?
yeah, not those ones.
Which one?
Cause go down.
Oh, this one?
Cause this one I got right, but I don't know why the slope is the average.
Because by definition, the word slope is average. Ha 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 ha.
Oh.
Yes, the word slope. Okay, the slope between two numbers is the average between the two what? Two numbers. Anytime you see the phrase like average rate, it means what?
Slope.
It means slope. And let me explain. Let's imagine that you had like a graph of, let's say, the speed of a car, right? At time, at time equals 3 seconds, you're traveling, let's say, like 20 miles per hour, and then you just start increasing really, really fast, right? And so it's not increasing linearly; it's increasing exponentially. But let's imagine that by the time you get to like t equals like 7 seconds, you're going at like 100 miles per hour. Okay. Now we know that the speed's changing really, really fast here because it's just increasing really fast. The question is, well, from time equals 3 to time equals 7, what's the average rate of change? Like, just kind of block off all the intricate details of how fast the car is accelerating. Can we just figure out the average? To do that, you find the slope between the two what? Two numbers.
Okay.
Yeah, and then now that's not going to be a very accurate picture, but just an overall what? Overall average of how fast your car went from 3 to what? 7 seconds. Okay, so average always means slope. Now in calculus, you're going to be looking at not average, but the instantaneous rate, which is literally the slope at 1 point. Okay, right there. So you can actually track how fast the car is moving at every millisecond of its travel.
Wow.
By taking the derivative. Or every second, and then you could even do that too, milliseconds.
All right, I think that's it.
Okay, Lily, any help on anything from your end?
No, I just had the 21 and 23, 23, 20. I don't remember those last two.
Okay, then all right, I'm gonna post one more of those to make you guys do it so we can all be on the same page. Okay, so go to your Freeform app.
Don't you need 19? You can just explain it to me later. I told you. Jeez.
I was busy.
Girls sometimes. Sisters.
Oh, 19 here.
Okay. Never mind.
I just saw 19 and I realized you cannot factor what?
19.
Okay.
Basically use Pythagorean theorem and those two are your critical values. And then it's
not the Pythagorean
theorem, the quadratic formula.
Yes.
And those two are your critical values. And then you just figure it out from there.
There you go. Okay, do it. Everybody do it.
But I already did it.
No. Then it should be easy for you.
That's true.
Wait, so use 1 from x squared and 8 from x? And just do the quadratic formula?
Mm-hmm. Good to use C though.
Okay, you know what? Here, let's do this first. Everyone, let's not use the quadratic formula. Let's do it the better way. Everyone, open up Desmos graphing calculator. Bam, bam, bam. And go ahead and graph that expression there, or that function, x squared plus 8x minus 5. Okay, now this is going to graph it as if it's set equal to what?
0.
Okay, so let me kind of rearrange this. So this is what it looks like. Okay, well, what are the two values that according to this graph will cause the expression to become a 0?
-4 rad 21.
No, decimal wise.
Oh.
Negative 8.58. You guys get that? Hello? Anybody home?
Oh, wait.
Are you guys still graphing it?
There we go. Sorry, no.
Oh, I said yes, but my microphone was muted again. I was like, I'm here.
Yeah, okay.
Okay, so you guys see that? Negative 8.58 and then 0.58258, that one? So those are the two places on the graph where the y values are 0. So that's equal to 0 here. Now, the graph tells us when the graph is going to be greater than 0 or positive. It's going to be here, that way, and what? All the numbers here are going to be what? Negative, because the y values are negative. Do you get it?
Yep.
Yeah. Okay, but again, we're going to use the number line test to show that. So those are the two numbers you're going to get from the quadratic formula. Okay, so the first critical number is negative 8.58, and the other one is 0.58. Okay. Do we want those two numbers?
No.
Yes, because we want it to be greater than or equal to what? 0. Now we have to test numbers below, middle, and afterwards with the interval line test. Okay, so plug in a number like negative
9.
like an easy one. I'll do negative 10, okay? Yeah. So if you plug in negative 10 now, we don't have a factor situation here, so we have to just plug it into this original one. So we're going to get 100 minus 80 minus what? Minus 5.
No, but it's a negative.
Oh, yeah.
But you'll notice we don't have to have the actual value. We know it's going to become positive, right? Yeah.
Yes.
Okay, which correlates with the graph. Everything to the left of negative 8.58 are all going to be what?
Positive.
Positive. And then if you plug in a 0 for the middle test, these two will turn to 0. You'll get a negative 5. So you definitely get a negative number here. So any numbers between negative 8.58 to that will produce a negative. And then plug in an easy number after 0.58 like a 1. So you get 1, 8 minus 5. That would definitely be a what? Positive. Okay, so your answer to this will be bracket negative 8.58 to left infinity or union 0.58 and positive what? So this will be your final answer. Okay?
Yep.
All right, any other question on this section?
Nope.
Okay, now there's a few more that we're gonna do before we move on. I'll show you. Before I post up the problem, so far we've been doing just factors that are horizontal, but what if you had something like this? Okay, so you had a fraction with factors on top and factors on the what? On the bottom. So if you have something like this, well, now you're going to have four different critical numbers, right? And when you plug it in, you'll get something like negative, positive, positive, maybe positive. Then this whole fraction will turn into a negative, which is less than what? Less than 0. Now, anytime you have fractions and you want to use the number line test and factor it, you have to have one fraction. So if you have another fraction here, you have to use common denominator and combine it. Okay? Okay, so for the next one.
I have two.
All right, you guys see it? Do you guys see it? Okay, so now this one, there's one fraction on one side, but a number on the other side. You want the other number to be 0. So you're going to first subtract both sides by what?
4.
By 4, okay? So 3x 5 over x minus 5, let's subtract 4. Now everything is with respect to 0 because it's much easier because you're either going to be positive or negative. Okay, what's your next step?
Get common denominator.
Yeah, common denominator. Now again, anytime you have a negative here with the fraction and you got to distribute it, always take your time and do this correctly. So many students have made mistakes with this. So before you distribute it in, I'll just write it out like this first. Okay. Now when you get better at this, yes, you can skip that step and just write it in. But everyone makes a mistake right here. They only distribute the negative to the first number, and they ended up not distributing it to the negative 5 right there. Okay. So we have 3x minus 5 minus 4x plus 20. Okay. See that? I distributed the negative to both the 4 and the negative 5. And then just keep simplifying. 3x and 4x will make negative x. Negative 5 and 20 will make positive 15. Okay, now you have parentheses on top, parentheses on the bottom. What's our critical numbers? Well, the first critical number is always with respect to the denominator. Okay, the denominator can never equal what?
0.
Yeah, so x can never equal 5. So I'll put 5 right here and put a what? Open circle. Now, for a fraction to become a 0, the numerator has to become a what? 0. Okay? But because we have to be greater than or equal to 0, we don't want the numerator also to become that number. So the number that we're thinking about is 15. You see it? So
Yeah.
I'm actually going to put 15 there, put 5 here. And now watch. If this was greater than or equal to 0, then I'm going to circle in what? The number 15.
15.
Yeah, because we want that. Because if you plug in 15 on top, you get a fractional 0 because the numerator turns into 0. Okay, I'm going to undo that. So, okay. Go ahead and test the numbers now. And you test it like this. For parentheses over parentheses, parentheses over parentheses. So we basically want same signs. Positive over positive or negative over negative. Okay, if you plug in a 4, you'll get
Positive
positive,
and
negative. So this will produce a negative. If you plug in a 6, this will be positive and positive. And if you plug in 16, you'll get negative and positive, which is what?
negative.
So what's our answer? The interval between 5 to what? 15.
15.
Okay, with open intervals. Okay, got it?
Wait, I thought it was touching with 15. Oh, no, never mind. That was just the example.
Yeah.
Let's try this one. Right, you guys see it?
Mm-hmm.
Uh-huh.
From now.
Okay, right. So what did you do for the top?
I factored out an x. Yeah.
Okay, what did you
Yeah.
do for the bottom?
Difference of squares. Yeah.
Okay, all right. All right, let's see if you guys can finish this on your own. I'm just gonna check your work. Yeah, and you should list all the critical numbers first, and then put it in order. But so far so good. You want to put some space in between too, okay? So
Okay,
that you can
got
put all the
it.
parentheses in there. And yep, it cannot equal 3 or -3. What about the numerator? This is Lydia's.
Huh?
Lydia, is
I'm
yours pink?
numerator. Purple?
Purple? I mean, purple. Did I just say pink?
Yeah,
Pink? That likes purple. It's purple. 0 and -2. Again, put some spaces in between because you have to fit all of those parentheses in between each interval. Yes. So we want -2 and 0. Oh my gosh. Yes, Lilia. Lily. Did I just call you Lilia? Oh my goodness. Lily makes put more space Fucking like, you know what came to my mind? Golem. Mister, makes a line the bigger. Precious. Make the
What?
precious line makes the bigger. Okay, so 0 to our critical numbers. You want those? We don't want 3 or negative what? 3. Okay. All right, so I'm gonna continue with mine here. So we got x equals 0, x equals -2, x cannot equal 3 or -3. So we got -3, -2, 0, +3. We want -2, we want 0. We don't want those two guys. All right, so we got 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4 of those. This is a lot of work. Okay, afterwards we're gonna see what this graph actually looks like. Okay, if I plug in the -4, we get negative, 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 which will become positive. And if I plug in a negative 2.5,
Oh.
be negative, 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 and positive, that will become positive, negative, negative. Yes, we want that one. If I plug in a -1, you get negative, positive, negative, and positive. So negative over negative, which is positive. And oops, no, we don't want that. If I plug in a number between 0 and 3, like the number 1, and you plug it into this situation, you get positive, positive, negative, positive, and you get negative. And then after 3, like a 4, so positive, 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 positive.
Oh,
Okay,
so the solution.
so do you guys get an alternating positive, negative, positive, negative, positive?
Yes.
Yeah, so it should be like this.
Man, my graph was
Okay.
crazy.
You guys got that?
Yep.
Yeah, good. So that's it. It's not hard, right? It's pretty easy. Lily, is yours still sinking?
Yeah, I finished.
Okay, so for those of you who are watching, sometimes there's a glitch with the iPads. When a student is finished, they're still waiting for it to sync. It usually means their internet is kind of slow. So you have to be understanding, because us privileged people have like gigabyte transfer speeds with fiber, but some people are stuck with Spectrum. This is like a Spectrum fiber commercial. All right. Okay, so good. Let's move on to, so we're done with that. Now, look at this one here. And I'm going to, okay, let's challenge problem. Here we go. Let's show the world. You guys can think now, like real mathematicians. But I have a feeling we're gonna drop the ball here. Okay.
Well, we are still dropping the ball.
All right. So
There's no equality or inequality.
yes, there's no equal sign. Okay, so we're not solving for anything, but we want to know what the domain is. Okay, we want to know what the domain is. Like, what x values can we use for this expression? Okay, so
What does that even mean?
any clue? Do you guys know? Do you guys know?
I think I know. Kind of
Like what?
like it can't turn into a negative and it can't have a denominator of 0.
Yes. So the fraction inside as a whole must always be greater than or equal to
0.
0. So we're going to pull this guy out because that's the whole thing inside the radical, right? Okay, good. I was really scared, but someone came through.
Let's go.
I don't know about the other two here, other two students.
Ha ha.
Okay, so this is basically what we've been doing this whole time, right? You guys see that?
Oh yeah.
I mean, it started off looking different, and then we realized as long as you understand that all the numbers inside a square root must always be greater than or equal to what?
0.
Yeah, now you just have to work with this one, and keeping in mind that for this condition also, you cannot have denominators equaling what? 0, except just the numerator, okay? All right, do we have to finish this, or you guys got it?
I got it.
Yeah, that's the only thing that was different about this problem versus the other ones, okay?
Okay.
Okay, let's move on to. We're done with chapter 1. Look at that. Here we go. Okay, chapter 2. Yes, you'll be given a chapter test for this. Okay, chapter 2. Let me show you what the topics are for generic Algebra 2 book. We're going to look at very easy stuff. Now, I'll show you that we pretty much covered most of these in our journey, in our math journey together.
This journey. Oh, look at this. This is beautiful.
Huh?
This journey.
Yeah.
What a road trip.
You guys? That car.
Oh yeah, I'll draw a car. I already drew one. Hey.
Okay, this is not art class. This is math class.
This is not arts and farts. No, I'm just kidding.
All right, so
It's
here we
off
go.
the road.
All right, there are 7 sections here. Guess what? We know how to do this. We know how to do linear equations of 2 variables. That's just x and y, and there are a bunch of what? Lines. We know how to do functions. You just plug it in. Graph of functions, and then there's a library of functions. Remember those 9 graphs I made you memorize?
Oh yeah.
That's basically what this is. So we already covered this. Analyzing graphs of functions is like looking at x-intercepts, y-intercepts, things like that. 2.5 shifting, reflecting, stretching. Do you guys remember that?
Yes.
Watch. If I do this, y equals x minus 3 squared plus 7. Which way did it shift?
Up. 3.
Wait, say it again?
This way. No. Yeah. No. The y-intercept is 7, and the x. What?
No, the y-intercept is not 7.
This is not in mx plus b form. Oh yeah.
This is not mx plus b. Okay, this is bad. This is bad. This is. Everyone's gonna be like, "What are you teaching these kids? This is a quadratic. This is not."
This way 3.
Oh yeah.
7.
Wait, what?
Yes.
This is the problem that shifted right 3, 1, 2, 3, and up 7. So now it's up here.
Okay.
Oh yeah, because it's the opposite.
Okay.
Because the opposite of what's in there.
Okay, I guess
the x-axis.
the Bible says pride before downfall. My pride just got crushed. My students don't know anything.
Same.
Okay, I know. Well, we've been going really fast, so fine. Remember, if there's a squared, it's a quadratic. It's not mx plus b.
B.
Anyways, so the only thing that we haven't really covered is the inverse functions, combination of functions. We actually did. Now we'll take you through these. I'm actually just gonna jump to the chapter review, and go until
Welcome to chapter 2!
you get stuck, and then we'll go back and recover those.
Take a look at our road trip. See, it's making Lily do the same thing. Wait, no, our road trip. No, that's not the one.
Yes, my class
Whoa.
is uncontrollable here. All right, look, review exercises
Wait,
chapter
you
2.
need to show the people who are watching this video our journey.
Yeah, our arts and parts.
Wait,
Now
where
go-
am I?
Now go up to the mountain.
That is not even a car. What in the world?
Yeah, it is. Go up to the mountains. That's where the journey really starts.
Haha, you'll never make it. See you at the top. Okay. All right,
Wait,
everyone.
What?
Where-
The dead
where am I
person
not
has to
Okay, Ian. This is chapter 2 of Algebra 2. This is how easy it is. Which of these letters have a slope of 3/2? Ian.
Oh, L1. What?
I'm just gonna hit stop. I can't record this anymore.
It's a positive slope.
Oh, yeah, I forgot.
Lily,
What?
Li- Lily-
I forgot.
Lily, can you
I
tell
thought
us?
that was- It's L2.
L2.
All right,
He was like,
Lydia,
"Oh,
what has a
L1."
slope of 0?
L3.
L3. What?
Do I get a
Lily,
reduction?
which one has a slope of -3?
Are you asking me?
Yes, Lily.
L1.
L1. And which one has a slope of -1/5? Ian.
L4.
How did you get that? Wow.
I don't know.
Okay, Ian. Let's see if Ian can handle this one.
Uh-oh.
A. By the way, just for all our audience who are watching, Ian is our most youngest student in the class.
L3.
It's not L3.
For B. Oh, we're doing A?
Yeah,
I
we're
don't.
doing it. Which one is undefined?
L2.
L2. Good. Okay, that's it for that one. And
Yeah.
then,
What? For.
I'm just trying to show you that we can actually legitimately skip this chapter. So take a look right here. Okay.
I like these.
We're not gonna graph it, right? What format are all of these in right now?
MX plus B.
Yeah.
Yeah.
Now for number 5, what kind of graph is 5?
It's a line. It's a horizontal line.
Horizontal line. And what about number 6?
6 vertical line at -3. Yay. Slice. Yay. Which is actually, fun fact, it's not a function. Huh? It's actually -3, not a function because it touches 2 points at the same
Okay.
time.
Guys, go to your respective places
See?
and try this next one.
People think I'm not smart. They just don't see past my mistakes.
Okay, read it and solve. It says here, use the concept of the slope to find t such that the 3 points are on the same line.
So, slope formula. I got to do -0.5 -1 equals.
Okay, does everyone know what to do?
-1. Yes. 5 -1. But yes, I do.
Ian, this is wrong. Oh my goodness, Ian. Okay, I'm not gonna call it Ian anymore because this is looking really bad.
It is right.
It's wrong. It's y values on top, not the x values.
Okay.
And
Okay.
here, 1 - 5, 1 + 2. Yes, that's good. And then for Lily, are you writing but not showing up?
Yeah.
Okay, we're gonna just call you Spectrum, okay?
Shame on Lily.
Okay, so basically find the slope between those two, and then set it equal to use another two coordinates, but with the letter t, and set it equal to that slope. So it'll be 1 minus 5. 1 plus 2, and that's going to give you a negative 4 over what? 3. So if you find the slope between these two now, 1 minus t over 1 minus 0, it should equal negative 4 what? 3. So 1 minus t equals negative 4 over 3. 1 plus 4/3 equals t, and it's just 7 over what?
Yes.
Okay, you guys get that?
Yes. Yes, I did.
Okay, good. Okay, give me the equation of
Ooh, point slope formula. I'm adding it. I don't know. Point slope formula is so great.
Now, why not?
0 minus 10 over 0 minus 6. What? Undefined.
All right, what's the equation? This one should be pretty straightforward. What is this equal? What's the equation of this line? Nobody knows?
Hold on. Ian said something. I'm gonna test him.
All right, guys. It's
Oh, he's
just,
right.
Well,
Right.
it is undefined because it's 0.
It's x equals 0.
least
That's
it
the
didn't have-
equation of the line.
Really?
What?
How'd you figure out that? Oh, because
What would this red one be?
x equals
What would this one be if it was negative 3 here? X equals
x equals
negative-
-3.
-3.
A vertical line is just x equals whatever number it goes through on the x-axis.
Yeah, and it goes those points. It goes through 0.
I'm not gonna post this on YouTube. It's gonna be sad. Great job, Mr. Chung.
I think we're really fun though.
All right. Okay. At least
Let's
get,
go
okay,
back close.
at least
You're
get
great,
this one
Justin.
right. All right.
Don't worry, I will. I will 33.3333 repeating threes get this one right.
All right. Take a look.
Percent, I mean.
Oh no.
What were you saying about getting it right?
Okay. Here we go. I'm gonna start with Lily. Is a function?
Yep. I said yes. No? Yes?
Wait, are you referring to this a right here or this a?
Oh, the bottom A?
Okay. Is this a function?
Probably not, judging by the way your smile froze on your face.
No.
No, it's not. It's not. You
Oh,
guys-
there's...
Lily, that should
No.
have told you off.
I'm blind.
His face was like,
I'm actually blind.
Okay, it's not
there's
a
two
function.
20s.
Oh.
There's two 20s. Are you
No, for some reason, I didn't see that 20.
together, Lily. Let's get the show going.
All right, Ian is. I forget it. Forget it. Lydia, is B a function?
No. Wait.
Wait.
Is
Hold on, I'm
B
getting
a
the mix up.
function?
Yes, yes, yes.
Yes. B is a function.
I'm getting the 2 grapes.
Next, me.
Getting the 2 grapes
All right.
mixed up. Sorry.
Ian, is letter C a function?
Yes.
Yes, it is a.
Let's go. Hello,
All right, Lily, one more
I got
chance.
another
One more
chance.
chance, Lily.
Yes.
Is letter D
Lily,
a
done.
function?
Yes, yes, yes.
Yes, it is a function. Okay.
Dude, the smile like
So-
flips on my dad's face. It's so funny.
No,
As
I
long
didn't
as-
see.
As long as the x value is not repeated again, It is a function. Oh my goodness. Ay, 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 ay. Okay, how about this one here?
He's not even saying you better get this one anymore.
Okay, I'm just gonna just straight out come out and just say, I think you're gonna get this wrong, Rolf.
Okay.
Not, so we don't disappoint any of our
Confidence
listeners.
boost. No, just kidding.
Okay, here we go. Determine whether the equation represents y as a function of x. Now, do you remember me covering this at all? No.
Oh, I think yes.
Okay, here. Let me give you like a side like lesson and let's see if you can apply it here, okay?
No.
When you have a function of x, that means you only have one y value for every x input, right?
Yes.
So if you saw something like this, like y squared equals x as an equation, and you're like, if I solve for y, what do you get?
Plus or minus x. No, plus or minus
x.
rad.
Oh, radical x, right? Okay.
Yeah.
But
Oh my
notice that
goodness.
that means y now has two outputs, a plus and a what x for one input. Does that make sense?
Yeah. Mm-hmm.
So this is not a function of what? Of x. It's not a function.
Yeah.
Yeah. Okay. The graph actually looks like this, by the way. Okay, so it violates the vertical what? Vertical distance. So try it. Like for number 35, is y a function of x?
No.
No, because if you fourth root it, you're gonna get a plus or what?
Minus.
Does that make sense?
Yeah.
Yeah.
How about
Wait, so
36?
wait, what does it look like? It doesn't violate the line rule 4 times?
No.
Why? Oh wait, no, only twice.
Yeah, because
Okay.
if you
Moving on. 36. Is 36 a function?
Yes.
Yes. Is that a linear
Yes.
equation? What about 37? Is that a
Yes.
function of x?
Yes.
Yeah.
Yes. Now, what
Yeah.
about 38? An absolute value of y.
Probably not. If the absolute value of x
If
looks
I have
like this, then
Lily, what do you say?
No, I said if I'd have to guess, I'd say no.
It's not. Okay. Now, why? Now, remember how absolute values work? Whatever's inside here is to be treated in two conditions, a positive y or a what?
negative y.
Yeah, and so what it's saying is the result of absolute value of y will result in two values of x plus y, a positive of x plus 2 or a what?
Negative.
Of x
Negative
plus 2.
x
Yeah,
plus
so
2.
you're going to have two values for y. And again, the way this is graphed is looks something like this, okay?
Got it.
Absolute values are supposed to be like this, right?
Mm-hmm.
Well, if x has it, but that violates that crosses the vertical line twice. Okay, let's try this one. 40. All right, scroll down and look for this. Look for problem number 40. All right, you see it?
Yep.
Okay, so do A, B, C, and D, and then I'll give you the answers for it later.
Wait, what was it? Ian. Oh. Oh. It looks like plus 1.
All right, what'd you get for letter A, guys?
2 cube root of 4. 16?
16.
I
Okay.
see.
You turn
I
the
see.
8 into 2 cubed, and you cancel that out. You see it?
Yeah.
Yeah.
All right, try letter B.
I don't know what to do with this one.
Well, that's all you can do. That's it. That's your answer.
Okay.
All right, try letter C.
Oh.
What'd you guys get?
81.
Negative 81.
No, it's
Negative-
81.
No, it's negative 81. Okay, you got to get your negatives down correctly on this one.
But it's -3 times an even amount of
First
times.
of all, Ian, you have like barely any real work written carefully. All right, look, you got to write like this. Okay. Negative 27, parentheses to the 4/3, and then this becomes negative 3 to the 3rd power, like that. Those two will cancel out, but you still have negative 3 to the what?
4.
4th power. Oh,
See? Oh my goodness.
it's
You guys
actually,
must be
wait,
blind.
it is a,
Hey,
it's positive.
wow.
81.
Look at that.
Oh, what?
I am so judged by my genius.
Wait, that I didn't.
You guys are such failures.
I
You
didn't.
don't even know you-
I'm not gonna post this online.
Hold on.
Hold on, guys. Nobody
Wait.
love you.
What if you did it on a calculator?
No, it's positive. I don't know why I put negative. Oh my goodness. Well, again, this goes to show that everyone can make mistakes. Blah 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 blah.
No, if you plug it into your calculator, it says it's negative 81.
But did you do the parentheses?
Doesn't make any
Oh.
sense. She didn't do parentheses.
That's
Yeah,
why.
it's positive 81. Okay, do the L, G to the negative X. Do that one.
I am so hot. No, I'm just kidding.
Is it just negative 4/3?
Yeah, it's just -x 4/3, right?
That's
Yeah,
what I
well,
meant
if
to
you bring
say.
it out, no, this will become positive X to the 4 what?
Ah.
Because the
yeah.
numerator will be to the 4th power. You get it? I mean, no, not the numerator. The exponent, the numerator of the exponent, which if you multiply it by itself 4 times, it'll become positive. So this is your answer right here. Okay. Okay, scroll down. Try that one, number 41. This is called a piecewise function.
Oh, what?
Piecewise. Wise pieces together. All right, h of -2. Now pay attention to this portion right over here. This is your domain, okay? So if you plug in a -2, what they're telling you is, if your x value is less than or equal to -1, plug it into the top one. You see it?
Mm-hmm.
So
Okay.
h of -2 should only be plugged into the very what?
Top.
Very top. So 2 times -1 plus 1 equals -2 plus 1. Okay, there it is. What about b? Where would you plug in b?
Oh wait, you did B already.
Huh?
Yes.
What?
Again, the wrong numbers to the wrong places. Okay,
Oh.
but yeah, A and B, you want to plug it into the
first one.
top. Yeah. 2 times -2 plus 1. -4 plus 1 is -3. And then for
0, you'd plug into the second one.
okay, so 2 times -1 plus 1. Okay. For 0, you'll plug it into the second one. Yes. So it'd be 0 squared plus 2, which is 2. And then for 2, you plug into the second one. Okay, pretty easy.
Yep.
Mm-hmm.
Okay. This one we're actually going to take some time to do this.
Yeah.
Please contain your yawn. This is when you mute your mic, okay? It's kind of like when you have to like let out some flatulence. You want to definitely mute it. Okay. 43. Determine the domain. Now, when we talk about domain, there's only three particular expressions that you have to pay attention to. Okay, domain. If it's not one of these three, it's most likely going to be all real numbers. So the first type is a fraction or a rational. All right, a rational expression when you have something like that. When you have an x on the numerator or an x on the denominator, an x on the denominator, you can have any kind of stuff on the numerator, but anytime you have something on the denominator with the letter x or a variable, there's a number that x can never become.
3.
Yeah, whatever. Okay, whatever will turn the denominator to a 0. Okay, so this is called a domain restriction. The second type is when you're dealing with even number roots. Okay, I put an E right here for even number like 2, 4, 6, 8, 10. So whatever this is, whatever's inside here has to be what? Greater than or equal to 0. Okay.
0.
The third type is your logs. Okay.
Huh?
And we'll look at that in a bit.
Logs?
Yeah.
Ooh, I want to do
X
logs.
must always be greater. For this, we'll learn this in a bit. This is in unit chapter 5 actually. X must always be greater than 0.
That's nice.
But now what you'll see often is a combination of a fraction and a what? And a radical. So you'll see something like this. See it?
Yeah.
So you have to apply both. All right,
Got
so
it.
take a look at the problem here. Okay, give me the domain for 43. What values of x can you plug in and not plug in to this equation? You should immediately notice something.
None. Actually, no.
All right, what's your first step? What's your first step? It's an even number square root.
Take it out of the radical and say it's and set it more than or equal to 0.
Yes, greater than or equal to 0. Good. Now this looks like the homework problems that you worked on for inequalities, right? Factoring and solving for inequalities. Okay, so you
I think it's an
for a number line. Good. Then plug in with a 0 here. Get positive, so it's positive, -6, negative, and negative. No, actually, no, that 5 minus -6 will become positive. This will be negative, and this should be negative. Okay, so the numbers you only want are 5 to what? 5 to 5. Okay?
Okay.
All right, now you don't realize this, but this is a particular type that you actually have to keep in your memory until like calculus. You're gonna see this everywhere, okay? This is actually a circle or the top half of a circle. How do I know that? Well, take a look at this equation. I'm gonna change the f of x into the letter y. Okay, yeah, I'll just use a different color. So this is y equals 25 minus x squared. Okay, what would happen if I square both sides?
Oh.
You get y squared equals 25 minus what? X squared, and then you bring the x squared to the left side, you get x squared plus y squared equals 25.
R squared.
which is 5
Oh.
squared. This is an equation of a circle centered where?
Uh,
There's no
0, 0, 0,
0. There's no transformation. And so 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This is a circle. Now, if this was given to you, okay, if it was written like this is what you would draw, okay? But it's not given to you like this. They gave it to you like this. Well, how did they get that? Well, just work backwards. They're basically going to just solve for the letter y. So again, just go backwards again. Y squared equals 25 minus x squared. And then if you take the square root of both sides, what do you get?
y equals
Squared
y equals.
minus 25 minus x squared. See that? The positive 25 minus x squared is the top portion right here. Okay? And then the negative 25 minus x squared is the bottom what?
Portion.
Bottom.
Okay. Now, to prove this, let's graph both of these. Go to your grapher and graph a positive radical of 25 minus x squared and just leave it like that, and you'll see the top half. And then graph the second one. Wait. Whose baby is that? That's my baby.
Oh yeah, that's so cool.
Wow. Whoa.
One half of the circle's red and the other half is blue because it's the.
That's
That's so cool.
Okay, did it work? Did it work?
You forgot to put in positive and
Yeah.
negative.
There it is. Okay.
Wait, what? Oh, you did plus x squared. It's negative. Oh, it's minus. There we go. Oh, look how cute it is.
Okay, then a negative radical, 25
Whoa.
minus x squared, and that's the bottom part. Now, I gotta reset this. Okay, there it is.
Guys, if you do one of the equations as radical 2x squared and then the other one is negative rad 25 minus x squared, it looks like the Grinch.
What? Oh, boy. Oh, no.
We're in the Christmas spirit now, aren't we? It's about the Grinch. Okay. Let me see here. There's
2
one more.
minutes.
We got about a minute and a half to win it.
This is the best recording ever. Babies crying, crazy students. You gotta put it up there. Maybe you'll get a bunch of subscribers because we're so funny.
Yes. Let's hope so. Okay. Well, we have less than a minute. Give me 45. S cannot be equal to. Hello? Anybody home?
Hold on.
My free form is like just blank white. Oh, there. Finally.
Got it? So that means you can have any numbers from negative infinity to 3 and 3 to positive what? Infinity, okay? All right, we'll have to park it here today and do the rest on next week. So I'll put up your homeworks. I'll see you guys later. Have a good weekend. Bye-bye.
Bye.
Bye.